Picture this. You're at 75,000 miles in a little turbo 4-cylinder. You've always run full synthetic. And the advisor walks out with a printout and a headache. Timing chain stretched, guides chewed up, maybe the turbo isn't happy either. Estimate? Somewhere between 5 and 8 grand. And you're standing there thinking, how? I use the good oil. That's the trap a lot of people are sliding into right now. The jug says full synthetic, the commercial swears you're getting maximum protection, and your brain goes, cool, I'm safe. But under the latest API CEQA and LSAC GF7 standards that rolled in around 2025, those big words on the front matter a lot less than the tiny codes on the back. Here's the catch. In North America, full synthetic isn't strictly defined. After the Mobil versus Castrol fight in the late 90s, severely hydrocracked Group III mineral oils were allowed to be marketed as synthetic. Today, a big chunk of the full synthetic shelf is Group III with a modern additive pack, not the PAO heavy blends purists think of as true synthetic. Even synthetic oil write-ups point out that full synthetic is basically a marketing phrase and that many of these oils are still built on Group III-based stocks from crude rather than lab-built Group I FeO. So the problem isn't that these oils are illegal or instantly destructive. The problem is the expectation gap. Different bottles can scream full synthetic at you, but only some of them are actually built and tested for the stress of a modern turbocharged, direct injected engine. That's where API CEQA and LSAC GF7 come in. Starting March 31st, 2025, API CEQA became the new gasoline category in the familiar API donut, and GF7A and GF7B replaced GF6 on the fuel economy side. Compared to the older SP and GF6 standards, CEQA and GF7 turn the screws in some very specific places. TAR sequence IX LSPI testing, tighter sequence X timing chain wear limits, stronger oxidation and deposit control, better cold temperature pumpability, and stricter limits on sulfated ash to protect gasoline particulate filters. Plain English version. If an oil carries API CEQA and LSAC GF7, it has passed more severe tests for the exact problems that kill modern engines. LSPI, chain wear, and oil breakdown over long intervals. If it doesn't, and it's still shouting full synthetic on the front, I start getting suspicious. Let's talk LSPI first, because that's the quiet engine killer almost nobody worried about 20 years ago. Low-speed pre-ignition is that super knock event you get in small turbo GDI engines when tiny droplets of oil and fuel in the chamber light off before the spark. Instead of a smooth, controlled pressure rise, you get a hammer blow on pistons, rings, and bearings. LSPI can crack ring lands, pound rod bearings, and in the worst cases trash an engine well before 100,000 miles, which is why the industry created dedicated LSPI tests like Sequence IX and baked LSPI limits into SP and then tightened them again for CEQA and GF7. Here's where the chemistry bites. The oil's additives are part of the LSPI story. Research from additive companies and lab studies showed that calcium-based detergent systems strongly promote LSPI events, while magnesium-based systems barely move the needle the same way. Calcium sulfonate and phenate detergents are fantastic at neutralizing acids and keeping piston crowns and ringlands clean, but in the harsh environment of a high-boost downsized turbo, they can help trigger LSPI if they aren't balanced carefully. Add high cylinder pressure, long injection events, and fuel dilution, and that bargain full synthetic with an old-school calcium-heavy package starts to look a lot less comforting than the label suggests. Now add timing chains to the mix. A timing chain is a long metal loop running through hot oil mist, loaded by cam phasers, and in many engines, by a high-pressure fuel pump too. It lives most of its life in boundary and mixed lubrication, which means it depends heavily on the films the oil lays down on pins, plates, and guides. When the oil shears down, oxidizes, or gets thin with fuel, those films weaken, the chain stretches, and the tensioner runs out of travel. API CEQA and GF7 respond to that with a tougher Sequence X timing chain wear test and tighter limits on allowed chain stretch. And the test is run on aged oil, not just freshly poured fluid that looks great for the first few hours. Formulators lean on a careful balance of calcium and magnesium detergents, plus surface active elements like boron, to build tribofilms that protect chain pins and plates without feeding LSPI. Some formulation work literally dials in the calcium to magnesium ratio and adds small doses of boron compounds just to keep chain wear under control while still passing LSPI tests. So when I say fake full synthetic, I'm talking about oils that brag big on the front of the jug but tell a very different story in the fine print. You've seen the pattern. Store brand full synthetic that only lists API SP, no CEQA, no GF7, and no modern OEM approvals. Bottles that claim turbo protection, but their datasheet never mentions LSPI. Pick European full synthetic that doesn't carry the ACR manufacturer specs real Euro oils put front and center. High mileage, full synthetic, whose cold cranking and volatility numbers line up more with older GF5 blends than anything truly current. If you hang out on Bob is the Oil Guy or watch the Serious Oil Nerds and Mechanics on YouTube, you see this play out in used oil analysis. People send bargain full synthetics off to Speedy Agnostics or Blackstone, and the reports come back with high fuel, thinned out viscosity, and more iron or chain-related metals than better oils at the same mileage. Engines don't usually explode on the spot, but over 50,000 to 100,000 miles, that extra wear is exactly what sets you up for the big timing chain or turbo bill down the road. Real talk. Your engine doesn't care what the front label claims. It cares about film strength at temperature, how fast oil reaches the chain tensioner on a cold start, how often LSPI events happen under load, and whether the additive pack is still doing its job at 6,000 or 8,000 miles. APICU and LSAC GF7 oils have to prove all of that in standardized tests. A cheap full synthetic that never moved past SP or GF6 and never mentions LSPI or timing chain control is already behind before you pour it in. Now let's plug in the accountant brain. Say a solid API CQ and GF7 oil from a respected brand costs $15 to $20 more per change than a store brand full synthetic that only hits the older spec. You change oil every 5,000 miles because you actually like your engine. Over 150,000 miles, that's 30 oil changes. $20 extra each time is $600 total across the life of that engine. Stack that against an $8,000 bill for a chain and turbo job or a replacement long block, plus towing, rental car, and days of hassle. $600 to reduce the odds of an $8,000 disaster is boring. Spreadsheet-approved math. I'm genuinely curious what you're running right now. Drop your combo down below, year, make, engine, mileage, the oil brand and viscosity you're using, and how often you're changing it. That mix says a lot about how relaxed or nervous you are about LSPI and chain wear. Have you ever seen a used oil report that scared you, or had an engine fail younger than 150,000 miles? I'd really like to know what oil was in it and how far you were stretching your intervals when it went sideways. So what's the actual blueprint for avoiding the fake full synthetic trap and getting real longevity out of a modern engine? First move is simple. Ignore the front of the bottle and flip it around. Look for APICU in the donut and LSAC GF7 if your car calls for a fuel-saving oil. If you've got a recent turbo GDI or hybrid and the bottle only lists SP or GF6 with no LSPI or chainwear language, that's a sign it's using the older playbook unless your automaker specifically blesses it. Next step, pull up the product data sheet on your phone. You want to see modern OEM approvals that imply LSPI and chain control. Things like the latest GM Dexos 1 gasoline specs, or updated approvals for newer Korean, European, or Japanese engines. Not just a vague meets or exceeds industry standards. And stay in the viscosity grade on your oil cap. Jumping to a thicker 5W40 just because it's synthetic can actually make LSPI worse in some setups and slows oil getting to the chain tensioner on cold starts. There's also the filter piece, which is its own rabbit hole. Short version. A quality filter with a proper anti-drainback valve keeps oil up in the galleries so the chain doesn't whip around dry for the first second after startup. Cheap filters that drain down every night quietly add to chain wear, even if the oil itself is solid. It's all part of the same failure picture. Here's how I'd run a modern turbo or hybrid I wanted to keep to 200,000 miles. I'd pick an oil that clearly lists APICU, and, if it applies, ILSAC GF7 on the back, plus the exact OEM spec the manual calls for. I'd use the viscosity printed on the filler cap. I'd start with conservative intervals around 5,000 miles and send at least one sample to Speedy Agnostics or Blackstone to see what my engine and driving pattern are actually doing to the oil. If the report shows low wear, controlled fuel, and stable viscosity, then I'd think about stretching a bit. If it shows high fuel, or climbing iron, I'd shorten up. Paired with a good filter, every time in a habit of actually checking the dipstick between services, that's how you stack the deck in your favor for chains, turbos, and rings. Last thing, pick a side. Are you a 5,000 mile oil change person? Or a factory says 10,000 miles, so I'm going 10,000 person? No judgment either way. I just want to see where people land after hearing about LSPI, timing chain tests, and the new CQ and GF7 chemistry. If one message sticks, let it be this. Full synthetic on the front of the jug is just paint. The real story is on the back, in those tiny APICU and LSAC GF7 markings, the LSPI and chain wear tests behind them, and the way calcium, magnesium, and boron are tuned in the formula. Get that part right, and you're buying years of engine life for the price difference of a few coffees per oil change. And once you've sorted your oil, the next rabbit hole is that little metal hanging off the